Welcome back. Today we are going to look at Chapter 7, Section 2, and we're going to look at some of the characteristics of the graph of a rational function. First thing we should make sure we remember is what an asymptote line is. An asymptote line is a line that the graph approaches but never crosses or touches. And we learned that back in one of the previous chapters before Christmas. And a vertical asymptote line is always written in the form x equals a number, and a horizontal asymptote is always written in the form y equals a number. So the parent function for simple rational functions is in the form y equals 1 over x, and the graph is a hyperbola. A hyperbola are these branches you see over here in the graph at the right. And as we kind of go through domain, range, asymptotes, things like that, the domain for a simple rational function is going to be all real numbers except 0. So we write that as all real numbers except 0. And the reason that it's all real numbers except 0 is because the horizontal line is at x equals 0, and that's basically the asymptote of the graph. The range for a simple rational function is all real numbers except for 0 also, because there is an asymptote, a vertical asymptote at y equals 0. So the graph has a vertical asymptote at x equals 0, and it has a horizontal asymptote at y equals 0. Which means the graph approaches the x and y axis but never actually touches it. So as we use Desmos to look at all of these different graphs, you can take some time to look at them. I just wanted you to see what happens to these graphs based on what the value of a is in the numerator as it gets bigger and smaller and things like that. So letter D down here is the parent function y equals 1 over x. And what I kind of wanted you to see is the smaller the value of a, so like 0.1 is very close to the origin, 25 pushes it further and further away from the origin. And again, the domain and range are going to be all real numbers except 0, and the vertical asymptote is going to be at x equals 0, and the horizontal is at y equals 0. Now we'll shift these graphs left, right, up, and down and things like that so that the asymptotes are not always going to be at 0, and the domain and range are not always going to be all real numbers except for 0. And then what I kind of wanted you to look at with these four graphs as you compare them to the parent function is that negative in front of the a value moves the branches of the hyperbola. So when a is positive, like on the last slide, the branches of our hyperbola were here and here in quadrants 1 and 3. When we make that negative, if you notice, it moves those branches into quadrants 2 and 4. Okay, so now we're looking at actually translating this graph left, right, up, and down. And it's much like when we had vertex form, when we did parabolas, how there's a value of h that moved it left and right and a value of k that moved it up and down. So a vertical asymptote is at h, and it shifts the graph left and right. And the domain is all real numbers except for h. Horizontal asymptote is at k, or y equals k, and it shifts the graph up and down, and the range is all real values except for k. So going back up here where it says the vertical asymptote is at h, technically we should say the vertical asymptote is at x equals h, because that's how we write the equation of a vertical line, and y equals k is how we would write the equation of a horizontal line. So as we're looking at this, first thing we want to find is the vertical asymptote. So we're going to basically figure out the value of x when the denominator equals 0. That's what the vertical asymptote is anytime that we're looking at these. So the vertical asymptote is when the denominator equals 0. So if I say x plus 2, which is the denominator, equals 0, I subtract 2 from both sides. My vertical asymptote is at -2. My domain is going to be all real numbers except -2. Okay, so notice these two numbers here, my asymptote and my domain, match up. So I'm going to go ahead and draw in that vertical asymptote at -2 over here. Then I'm going to look at my horizontal asymptote. My horizontal asymptote is my value of k. So my horizontal asymptote is going to be y equals -1. So I'm going to draw a horizontal line at -1. And, oops, didn't go. There we go. And since the value in our numerator is negative, that means that our graph is going to be in quadrants 2, or the branches of our hyperbola are going to be in 2 and 4. And over here, we forgot to write down our range is all real numbers except -1. Again, these values here, my horizontal asymptote and my range match up. Here's another example. My vertical asymptote is when the denominator equals 0, which means my vertical asymptote is going to be at x equals 0, and my domain is all real numbers except 0. And my horizontal asymptote is the value of k, so that's y equals -2. And then my range is all real numbers except -2. Again, notice my vertical asymptote and my domain match up, my horizontal asymptote and my range match up. So when I go ahead and make my asymptotes, I'm going to be at vertical at x equals 0. My horizontal is at y equals -2. And my numerator 3 here is positive, so I'm going to be in quadrants 1 and 3. Okay, one more of these that we did here. My vertical asymptotes when my denominator equals 0, so that's going to be x equals -4. And my domain is all real numbers except -4. The horizontal asymptote is my value of k. Well, technically there's nothing added on there, so I'm going to be at y equals 0. And my range is all real numbers except 0. If I go ahead and graph that, I'm going to have a vertical asymptote at -4. Horizontal asymptote is 0. And we are going to be in quadrant 2 and 4. Okay, we've done several of these. I'm going to go ahead and skip this one for now and look at other rational functions. This is slightly different form because if you notice, the simple rational function just had a number in the numerator and then a binomial in the denominator with the number added on afterwards. This has an x in the numerator and the denominator. So the vertical asymptote is the graph of the line x equals -d over c. Or, easier way to think of the vertical asymptote is when the denominator equals 0. Okay, and the horizontal asymptote is the line y equals a over c. Well, if you notice, a over c, oops, daisies, I didn't mean to do that. And a over c is just the coefficients of the x's in your original problem. And your domain and range are going to be the same idea. Your domain and range, your domain is going to be all real numbers. The domain is going to be all real numbers except for whatever value you got for your vertical asymptote. And the range is going to be all real numbers except for your horizontal asymptote. So looking at an example of this, the vertical asymptote, again, is where your denominator equals 0. X minus 3 equals 0 would mean that x equals 3. Your domain is all real numbers except 3. Your horizontal asymptote is going to be the coefficients of x. In this case, that's 2 over 1. So your horizontal asymptote is going to be y equals 2. And the range is all real numbers except 2. So if we put in our vertical asymptote at 3, horizontal asymptote at 2, and then we're just going to put in the branches of our hyperbola in 1 and 3. Okay, last example here of when we have it in this form. We would have, what is the vertical asymptote? Well, that is when the denominator equals 0. So if 2x minus 6 equals 0, if we add 6 to both sides, we get 2x equals 6. Our vertical asymptote is at x equals 3, and our domain is all real numbers except 3. Horizontal asymptote is the coefficients of x. In this case, that's 8 over 2, which means we are going to be at y equals, that color, y equals 8 over 2, which is, I think I said 2 a second ago, 8 over 2, which is 4, and our range is all real numbers except 4. So let's go ahead and draw in our vertical at 3, our horizontal at 4, and then our branches of our hyperbola are in 1 and 3. Thanks, good luck, and have a great day.